My name is Mike Wood, and I am here today to talk to you about message patterns. As you can already tell from my accent, I am not from around here. I am actually from the States. I'm from that part of the States that, kind of where, right about there. That's usually the part that everyone flies over. It's not quite the middle of nowhere, but it's really close to it. But if you ever need to get in contact with me, my contact information is down here at the bottom. It'll also be available at the end of the talk. Feel free to tweet at me or send me an email. If you want a dead tree version of business cards, they're up here. I work for a company called Cerebrata. Has anybody ever heard of Cerebrata? This does not surprise me. Has anybody heard of Redgate Software? Okay, a lot more nods. Okay, so Cerebrata is owned by Redgate Software, and we are a group within Redgate that produce Azure development tools. But that's about all I'm going to say about the products. If you're interested in what we do, catch up with me either after the session today or tomorrow, and I'd be happy to talk to you about those. But today, we're actually going to talk about message patterns, and I want to set some expectations right up front. Well, let me take a poll here. How many people are actively using a messaging framework in their solutions today, such as RabbitMQ, MSMQ, Central Queuing Service from Amazon? Okay. So for you folks who have raised your hands, this is an introductory talk about messaging patterns. I hope to cover some things I've run into on teams that I've worked on that may be of use to you, but if you have already got a very large-scale distributed system running and it's running well, you're probably not going to get a whole lot out of my talk, okay? I'm just going to be upfront with you there because I know you guys have paid to be here, and I want to make sure that you're in the sessions that you're going to get the most value out of. However, if you are new to messaging, or if you have just a few things that you have done with messaging, then by all means, hopefully you will get more out of this talk than those who have been doing it a while. I just want to set the expectations up front. The gentleman that left, that's awesome, because if they fill out an eval, they won't say too small detail, right? So we'll go ahead and get started. So what problem are we actually trying to fix here? So probably everybody in the room has gone out and ordered something from Amazon or some system online, right? And do you guys remember what that process was like 10 years ago or 12 years ago? You would go to a website, you would find what you wanted, you would select it, you would put it in your cart, you'd click a button, and right underneath that button would be small tiny print that says, do not click this more than once, right? You guys remember that? And then there was the don't refresh your browser, all these different things, right? And the problem was because that was posting up to the server and they were doing the entire processing chain in the back end, including charging your credit card. So if you click the button more than once, the request got sent to the server more than once, and credit card got charged more than once, right? Not a very ideal situation. Now it's very different. You go, you order what you want, you click the button, and the next thing you find out is just a screen that says, hey, thank you for your order. But a few minutes later, you get an email that will say, we've now processed your order, thank you very much, and now you know it's actually ordered. Sometimes you'll get an email that says, I'm sorry, that's now on back order, right? And that's because they have broken apart the user clicking the button from the actual processing on the back end. So the reason I have this picture up here is my brother back in the States is a real estate agent. And that's not his name. This is just a Creative Commons image. I'm not trying to promote real estate in the United States. But in discussions with him, I found it very interesting just how far behind the real estate agency, or at least his company, is in technology, right? They use, has anybody ever heard of squirrel mail? Has anybody heard of this? Yes? Okay, you're the first person I have ever run into that has used it. I had never heard of it. And it's not to say that it's a bad system, but a lot of the things that they use are either antiquated or just aren't set up well. And so he was talking about it would be awesome to have an app to show up at a house, walk through, write down all the information about the house, how are we going to sell this, package it up, how many rooms does it have, how many bathrooms, et cetera. And then post that up. So he was looking for something like this. So we're going to go out, we're going to gather the data. That data is going to get saved, we're going to process some photos, right? We're going to update search, and we're going to push. notification to people to say, hey, if you happen to be interested in this area, or you happen to be interested in a 4-bedroom apartment or a 4-bedroom condo, then they become available. Now the problem with this is if it was designed front to back as one process, this doesn't scale, right? And this is why we need messaging. This actually will break apart the work that's being done. And besides, the user only cares about this little section here. Just like when we were ordering whatever from Amazon. We only care about click, yes, they got it, now I can go on to my day, and I don't have to care about the little robot that's running out on the Amazon floor finding this thing. So we break this apart, and we put messaging in the middle. Now we can scale this back end a lot better, right? Because this processing could take quite a bit of time, and the server receiving the request can simply gather up the information it needs, drop a message onto a queue, and move on, right? And that's really what we're going to be exploring today. This is also great that I actually get to come and speak to a culture that's already got a lot of computer science knowledge just built straight in. Because you guys know what this is already, right? It's a line. I actually have to explain that sometimes, right? However, speaking of you guys having a computer science culture, you're already zero-based, which is hard for Americans. We come over, we go into a building, and they're like, well, that's on the first floor. And you're like, okay, which direction? And they're like, up. Okay, so we're more VB-ish in that way. So when we're talking about messaging, we're usually mean queues. And from this point, in a very simplistic position here, a queue is we have a producer on one side. He's going to then want to talk to the consumer on the other side. There's some bit of information that he wants to share. And so he packages it up, he puts them in messages, and places them on the queue. And the consumer on the other side is pulling those messages and processing them. Now, it doesn't really say what's in the message. It doesn't really say anything other than I have a producer and I have a consumer. They're going to be processed in general in FIFO, or first in, first out. Okay? There's a lot of different types of messaging frameworks out there. There's RabbitMQ, there's MSMQ on an on-premise Microsoft world. There's service bus queues in Azure. There's storage queues in Azure. There's simple queuing service in Amazon. There's a lot of them out there. But what I'm going to try to go over today is certain patterns that you can use pretty much with any of them, right? Some of them will have features built in that I talk about, and some won't. My expertise is actually in Azure. And so I will be pointing out certain features that either the Azure storage queues or the Azure service bus brokered messaging have built in. But these are Azure frameworks that you can use, or messaging frameworks that you can use from Azure as a service. So before we go too far, we talked a little bit about what a consumer is and what a producer is. We'll talk about the purpose of durable messaging. One of the reasons that messaging one of the most important things that messaging can do is have a durable messaging system. What this means is when I submit that message, I know it's delivered. And then I know that it is saved to disk on the other side, or at least persisted in some mechanism so that it can guaranteed to be picked up by one of my consumers. Now, there are some messaging systems out there that by default persist it, or they have an option to say, no, keep it in memory, right? And there's a lot of them out there that keep things in memory simply because it's faster, right? They don't have to write to disk, they don't have to worry about that, it's in memory. But obviously if the machine goes down, that could be a problem unless they're duplicating that memory across multiple machines, right? So you could lose messages. Just be aware that your messaging, when you're choosing a framework, does it have durable messages, and is it okay if some of my messages may go away from time to time? That may be possible. There are people in the room that, if they're dealing with ordering systems, that would be going, no, you cannot let the message go away, right? But then there are other people that are like, no, I have a device that's sending me, status information every 5 minutes. It's okay if it doesn't make one, right? If I get the next one, that's fine. So another way that durable messaging is handled is once it's persisted, now we have to deal with what happens when a consumer is pulling that message to actually work on it, right? And then put it back. If there's a problem. So several of the systems work on a timeout, basically. And both the Azure systems work on this timeout, where it goes, the consumer will go to the queue and say, give me a message. And it either tells the framework, I will take 2 minutes to fix or to process this, or the framework says you've got 2 minutes to fix this, right? Either way, there's a timeout that if it goes beyond that point, then the message, we don't know if it's complete. Did we finish processing it? Did it blow up? Did the machine, the consumer, actually get it and go away? Who knows? So at that point, the framework makes the message reappear back on the queue. So in many cases, what you're doing when you're saying, give me a message, it's not actively pulled directly off the queue. It's still there. It's just invisible. So in some cases, you can set the timeout. Like for Azure Storage Queues, you can actually tell it, hey, when I get a message, for each message, I'm going to take this long to process this. And you can actively even go back and say, no, I need a little bit more time. Extend the message, extend the message. But the framework is always getting that, or the infrastructure is always getting that, hey, yeah, he's still working on it. Hey, he's still working on it. That's OK. But for brokered messaging or service bus messaging, it's a queue setting, right? If you go up and ask for a message on the queue, it's like you have this amount of time to take care of that. Otherwise, it's going to appear back on the queue message. Which is really interesting, because this is called at least once delivery. Anybody see a problem with this? Anybody? I see a bunch of smirks in the audience, right? Because you can end up getting the same message twice, right? 2 different consumers could pick up a message and end up starting to process it. And effectively, they're duplicating work. So this leads to something about idempotent or idempotent, depending on how you want to pronounce it, processing. And the whole point behind this is each step or each message that needs to be processed, you need to have, or have at least thought about, idempotency of the processing of that message. So for example, if you are rolling out scripts or new data to push out to a SQL server, right? And maybe you're adding a few rows into a message or a lookup table. Well, if all your script does is say, insert into this table these 2 rows, right? And maybe you've got auto-indexing on, right? So it's always adding a new primary key for you. Well, if you just keep running that, you're just going to get duplicate rows and duplicate rows and duplicate rows, right? And so a lot of database developers will go in, they'll look at it, and they'll put in the script, hey, are these rows there? No, insert them. If yes, then don't do anything. That script is idempotent. No matter how many times you run it, it's going to be fine, right? Same thing when you're thinking about processing pieces, right? So you need to analyze each step and decide, is it OK if this processes more than once? One example that's very common if you go through Microsoft documentation about storage queues is we're going to upload an image, we're going to take this image, we're going to turn it into a thumbnail, right? And then we're going to place the thumbnail over in this other storage. Well, if you think about it, that's idempotent. As long as I am constantly resizing the exact same image to the exact same size, placing it in the exact same location with the exact same name, then I can do that all day. And it doesn't matter, right? Sure, I lose some processing, right? I'm constantly redoing the same thing, but it doesn't matter. The outcome's the same. Compare that with a credit card. If you use a payment gateway and you go out and charge that credit card, well, when you go out and charge that credit card again, it's actually going to do that, right? Now, your payment gateway on the other side might have some way of detecting that, right? But again, you have to determine, is that going to be a problem or not? So now we're going to actually get into what are called some of the patterns. Now, just like software patterns, this is not prescriptive, you write it like this, okay? This is more along the lines of, this is a problem that people have come across, ways they have solved it, and I'm not going to dig into any code, really, okay? Again, this can be used for pretty much any messaging system you've got. So the first one is competing consumers, and this one is very, very simple and really easy. We do this for 2 reasons, right? We have 1 or more producers in the back end or in the front end pushing messages on the queue, right? And then we've got multiple people or multiple consumers on the back end actually processing those messages. We do that, so he'll ask for one and the other one will ask for one and they'll process. We do that for scalability, right? Now, if this queue gets really deep, meaning it has a ton of messages in it, I can spin up more instances in the back end to process the messages faster, right? If you think about the ordering scenario I gave earlier from Amazon, if they suddenly get a huge rush of people ordering, and a bunch of messages come in, they can scale up to handle that on the back end. However, and this is a problem that as soon as you introduce messaging into your system, you have to think about this, ordering and grouping, right, or sequencing. If you have a system that requires you to order and group your messages, so 18 messages come in and I need all 18 of them to complete, right, or if 18 messages come in and I need to process them exactly in order, you have to be very careful and understand that a lot of messaging systems don't do that for you directly out of the box, right? They will guarantee that you'll get the message, you'll pull it off, but you're not going to guarantee the order in which you get them. Remember the whole durable messaging and how the message could reappear back on it? You need to keep that in mind. So as soon as you need ordering or grouping, you need to rethink, how am I going to do that with messaging? Sometimes people handle that with keeping track of all the messages that come in. I know that I'm going to get 6 messages, and so I'm not actually going to do any processing until I know I've got all 6. And if there's some time frame window that I should have received all 6 messages, I should alert on that, things like that. But that's outside of the messaging framework itself. Okay? So one thing that Azure Service Bus brokered messaging does to alleviate this to some degree is a feature called sessions. And I believe a couple of the other ones have, or a couple of the other messaging frameworks have equivalents of this. But the concept here is each one of these consumers doesn't ask for an individual message right away. What it does is it says, I want a session. And a session is just a grouping, a loose grouping of related messages based on a session ID. So for example, this consumer up here can say, give me a session. And the infrastructure hands it and says, you're going to have session A because I've got messages in my queue for session A. And then the consumer can say, all right, well, give me the first message in session A, and he'll get that, and he'll process it, and then he can ask for the next message. But even though B was in the pipe first, he'll only be handed A's. And he'll be basically handed A's in FIFO order, right? The trick is that consumer is the only one of the consumers that's receiving messages for that group or that session. So now you can kind of compartmentalize and say this consumer is the only guy that's going to process these messages. Yes, sir?
Sorry, the overall queue isn't FIFO.
Sorry?
So the overall queue isn't FIFO, yeah?
The overall queue you couldn't say is FIFO because of the sessions. Yeah, it will, but for example, right now, this is empty of A messages, right? So when the consumer here goes back and says, hey, give me another A message, there aren't any. And then what your code would normally do at that point is you would relinquish session A and say, give me another session. And then you would get a session that has messages in there for that session, right? So
it's making the assumption that you have all the session mails. So you gave the example of 8. There were only 2 on the queue.
okay, so that's a great example. So the statement here is, the observation is, that makes the assumption I've got them all. Not necessarily, right? So the assumption is, I was expecting 8, I only had 2 in the queue, I pulled off those 2, I'm not done yet. But at this point, I can't then let my consumer sit up there and go, well, I'm going to wait for the other 6 to come in, right? So that releases A. I can save state on A. I can actually have a little bit of place that I can save state in Service Bus brokered messaging and say, for session A, save this little bit of state, telling it how many messages I have at this point, right? And then when A messages start to appear in the queue again, one of the consumers will ask for a session and eventually be given A. And then he will pull that and he can look at state of where it was and then start processing the other messages. Does that make sense? So yes, nothing in Service Bus sessions tells you how many messages there are or if you've got them all. You have to kind of work that in on your own. Halo, the video game, actually uses this. Halo 4, I think it was. When they complete a game, every one of the consoles sends messages using a game ID, which is a GUID, I believe, as the session ID into the system. And each one of them know how many players were there, right? And then all that information is stored up, and they've got processors on the back end that are consuming those messages, and they find out all sorts of analytics about a game, right? They track all sorts of weird things, like how many people were playing, what kind of guns were people using, what guns were they using when they killed this person, at this point, where were they on the map. They record a whole bunch of stuff. It's really interesting to look at how they use that and then analyze it. They will also turn around and analyze things for cheating, right? If they start to detect patterns or just obnoxious people, right? So the game starts up, and in the first 5 seconds, everyone mutes this one guy. Well, he's probably not being overly polite on the over-game chat, right? And so they can actually set up things where he's just auto-muted. So it's really interesting. So with ordering and grouping, you have to think about this. Does my system need ordering and grouping? And if so, how am I going to get around that? And as I mentioned, some people do it where sessions, with Service Bus you can use sessions. Other people do it with just headers on the message saying, I am 3 of 6, right? And then the backend system gathers all the messages up, saves them off to a database most likely, and then when it realizes I've got the last one, then it goes off and does processing, okay? Possibly even throwing a message on a different queue to do that processing. So all of the messaging frameworks have some sort of limit on the size of the message that you can put on the queue. For Azure storage queues, it's 64K. For Azure Service Bus brokered messaging, it's 256K, right? Yeah. So some people are like, that seems kind of small, that seems kind of limiting. In most messaging systems, you don't want it to be able to take a 16 meg queue message, right? Because now you're tying up the endpoint for your infrastructure to dump this whole thing up there and the other people to pull it off, right? You want that to be pretty quick. So other ways you can get around it, especially if you're dealing with images or large files, is you can do what I call ticketing, and that is the producer will take the message and place it in another persisted store, whether that's blob storage for Azure or S3 for Amazon, or if you're on premises, maybe it's just a distributed file system, right? You're just putting it out on a file share. Anywhere that the consumers can actually reach it, right? And then he throws a message into the queue. When the consumer picks that up, he looks at the message and says, okay, the payload for this is actually over on this other location. I'm going to go ahead and go over and grab it. That keeps this pretty small, right? And that keeps that fairly large, or allows us to put in larger messages or deal with larger things. So he can grab it. So the good thing about this, it does allow us to handle those larger payloads. This increases complexity. Anytime you're introducing new bits into your system or new dependencies, you're increasing complexity. And you're going to see this throughout the presentation, where introducing messaging just by nature increases complexity. So you need to be careful of this, right? And make sure that people are aware that that's what's actually going on. So any questions about the ticket? Okay. So for another pattern is the public and subscribe, or publish and subscribe, sorry. Pub sub. And the theory here is, so far we've talked about a producer puts a message on a queue, and then a consumer, one or more consumers, processes that one message. But what if there are other systems that care about that message, and you want to actually distribute the messages to multiple people, right? Think about a university, right? And on the university, you get the admissions system. And the admissions system, student comes in, he gets approved, and then we push a message out on a queue. So who cares about new students? Well, you've got billings, they definitely care about a new student, right? You've got housing, maybe the student needs to live on campus or wants information about campus. You've got maybe the department that the person wants to actually major in, right? So all of those people actually want to be alerted. So with a publish and subscribe system, basically the message comes in and then is duplicated and handed off to multiple subscribers. And then each one of them can process it in their own way. This is going to provide you a lot of flexibility. Number one, because the producer doesn't even really have to know anything about what consumers there are and who's listening for it. He just knows, I'm going to produce a message in this format with this information. Other people will deal with it, right? So it provides us a lot of flexibility on the back end where we can add new people that are interested in that particular type of message. It also decouples our processing steps. So if you think about earlier, in my real estate example, we had push and update search. They were all in that line, right? Well, maybe those aren't really related to each other, right? Maybe I can update the search independent of actually pushing the notifications, because the notification push may have a direct link to the actual item on the website or in the app, right? So they're not going to be searching for it right away. And eventual consistency means that this update will happen at some point, so I can separate those steps. Again, providing a little bit more flexibility. So Azure Service Bus brokered messaging has something called topics and subscriptions, and that's how they implement publish and subscribe. And the concept here is they drop it to a topic. So a topic is just something that somebody wants to know about. But to the producer, it just looks like a queue. It just has a different address. But other than that, it's the same. The code to actually post to it is the same as posting to a queue. So they can take the message and pop it on. So then we have subscriptions. And these are the individuals. They acted like little sub-queues, if you will, to say, I want to find out about a new listing, right? So when messages come in, they're actually then split, and each one of them get a copy. Now, I'm going to give a little hint, and then I'm going to ask a question. So the hint is, have you ever heard the phrase, if no one is in the woods and a tree falls, does it still make a sound? Right? If there's a topic and there are no subscriptions and someone posts a message to it, what happens to the message? Disappears, exactly, right? It doesn't like save them up until someone decides to subscribe to it. It makes the assumption that if no one is subscribed to the topic, then no one cares about these messages, okay? And they'll just disappear, poof, gone. So that's a gotcha if you are using topics and subscriptions and you have some sort of automated thing that's adding subscriptions and removing subscriptions. They do have a mechanism that you can put in place where you can have what's called a catch-all subscription, where it basically says, if you haven't delivered to anybody, deliver to me, right? And then that way, if somebody removes all of your other subscriptions, you can at least catch the messages that come in. Some people also will use that, they'll just say, hey, I'm going to add a subscription and I'm going to get every message that comes in, and I'm going to use that as an audit, right? An audit log. With these subscriptions, you can also actually filter them. So for example, the person or the Department for Housing, they may put in a subscription filter that says, I only care about students that are under a particular age, right? Or have actually flagged a little thing on the message saying, I am interested in students who have indicated they want to know about housing. Now, I will point out that this does not let me go look and dig down into the message content. These have to be headers or flags that you have set on the message header itself or on the envelope, not the actual object inside, okay? Or the data inside. Questions about topics and subscriptions? All right. So what if your steps are actually dependent on each other, that you have to process in a particular order? Another pattern you can look at is called pipes and filters. This actually allows you to process in order. Now you could do it the way that it was that I had on the first screen, where they're all in a line and you have one consumer that picks them up and runs through all the processing, right? But if you have pipes and filters, this is going to open up the world to you a little bit and provide you a lot of flexibility. So all that it really is you have a pipeline of individual tasks and processes that need to occur. And then you have what they call filters, which are these processing steps, okay? At some point, it's called a filter. It may not do anything to the data. It may just process and pass it on, or it might actually filter it out, depending on what you're attempting to do with your pipeline. In this particular case, I wanted to actually go all the way to the end. And so they're just queues individually broken up, and the process photo will look in the queue, pull that message, do the processing, and when he's done, he'll pass it off into the next queue, okay? And so on until it's done. Now, something that's really nice about pipes and filters is the flexibility to just completely change it and add a whole other step, right, in your pipeline. And you can even do this dynamically, right? So what's nice about this is, for example, the real estate agency. They may be selling this as a service. Here's the app, and then where agencies come and they pay for us to use the app. We always process images, but for our premium customers, we want to add their watermark of their company in the bottom of the image. That way, no matter where that is displayed on the internet, it will have their logo on it, right? So we can charge for that, and we can add that in dynamically. So if a message comes into the system and it's this customer, okay, I'm going to go down this pipeline. If it's this other customer, I'll go down a different pipeline, right? Now, there's a couple of things that are really good about this, is it reduces our step complexity. Each one of these steps is really independent from the other. They don't really have to know what the other ones are doing or care. That's kind of nice. It simplifies the code. Composition, we can put these things together however we want. Note that you need to be very aware that if there isn't a process order that you have to have, your system is going to need to enforce that, right? Or you're making a decision that I don't care if we get these out of order, they're configured to be in this order, so they should be fine. But you're making that choice at that point. So you can scale these steps separately. Now this is, in my opinion, one of the bigger helps of pipes and filters, especially if you start talking about some of these processing steps can be very lengthy in time or need to be, have special resources or high compute requirements or something like that. I could be processing these all in the same machine. Just because I have separate consumers here doesn't mean that that all the messages aren't being processed on the same box, right? There's just different processes pulling messages on the queues and doing the work. But if perchance I have something that really needs to be on its own set of boxes or consumers, I can certainly do that. And now that it's broken apart, these consumers here for the watermark, I can scale those independently. If that gets behind, I can scale only that set of machines up. Rather than saying, oh, well, my whole process is all on the same machine, the watermark guy is really dragging me down, now I have to scale everybody up, right? It also allows me to handle restricted resources. If you have a scenario where you've got an app or you're using a special third-party tool that has licensing requirements, and that thing says you're okay to use it and install it on 5 machines. Okay, well, if I'm doing all my work on the same set of consumers, I've now constricted myself to 5 consumers for everything, right? However, now, if I scale this out and break it apart, I can scale that up to 5, but then still up in my process photos, maybe that takes even more and I need more machines to do my work. I can scale that up even higher, right? Does that make sense? Cool. Everybody thinking about the next brownie yet? No? Okay. So, increased overall complexity. This is the one that, in my experience, has really bitten people, especially new people, because this looks a lot like magic. A message goes into the system, and a bunch of stuff happens that I can't trace in code, right? I can't go F12, go to definition to figure out what's going on, right? You have to know how the system works, and you have to understand that it can jump around. And if you, by any means, do this dynamically and create your pipeline dynamically, you really have to understand how those rules work. So just be aware that you're making a decision to make this complex. It's not necessarily a bad decision, but put things in place that allows people to follow what's supposed to happen. This is usually that big D word that no one actually wants to do, and it's documentation, right? But I have been on projects that we've come in to help or work on, and they didn't document any of their messaging. And it spent a week or 2 going through the system trying to figure out what are the possible paths through this, right? Now, the other thing this can introduce is duplicate messages. Now, you can always have duplicate messages, but pipes and filters I have seen cause it to happen more likely. And what's happening is, remember the durable messaging, right? Consumer goes out, grabs a message from this queue, he's working on it. When he's done, if he goes over here and tells them he's done on this message before he adds this message over here, well then, and then dies, well, you're stopped, right? The process just stopped. So instead, he pulls the message over here, he finishes his work, puts the message over on this one, and then he goes back here and tells him he's done. Well, from the time that this message is there, and this going back to tell this message that he's done, he could die. And when that happens, the message is going to reappear on that queue, and now you have a duplicate message, because another consumer is going to pick that guy up and start working on it. There are some frameworks that have things built in to deal with duplicate messages, okay? If you're working with one that doesn't, you need to think about this. What is our system going to do if it gets a duplicate message? Now, if your processing is idempotent, like we talked about a while back, it'll be fine, right? Some people will look at it and say, well, each message is tagged with an ID, and in my own database, I'm tracking whether or not I have processed that message or not. That's another way to do it. And some of the systems, like the service bus brokered messaging, does have duplicate detection built in. So it has a message ID, and if a message ID shows up, basically it tries to be delivered to the same queue during a time frame that you define, then it just disappears. It's like, I already got that, right? You don't get an error, you don't get told, right? Because it's assuming, well, that's probably a mistake. So it just ignores it, okay? So be aware of whatever framework you choose, can it detect duplicate messages? And if so, how does it do it, right? So that you're aware of how your app is going to react to that. Okay. Priority queues. Now this is something that usually gets asked quite a bit. It generally doesn't start this way. You'll have a messaging system and it'll be fine, and then someone will go, you know, we really have this one message that needs to get processed before the others. Can we just pop it in there and you pull it off? It's like, well, that's not FIFO at that point. I would argue that there's no such thing as a priority queue. That's called a stack. And you just know, well, not even a stack. Here's a heap of stuff, and then you can go in and pull out what you want, right? But priority queues often come up or at least in my experience, have come up in two different ways. One, we had a queue that was just a command set. So this is a command queue. Every message I put in there was a command to something. Let's say it was a machine, right? And I can tell it slow down, speed up, stop. Well, that stop is probably a high priority message, and it doesn't matter if there's 15 of them in the queue, you want it to stop right then, right? So that's one reason that people will look at priority queues. Another is just, hey, we have this customer, a gold-plated customer, and we want their stuff to be processed before everyone else's, right? That's an option. Some people sell that as a upcharge, right? So how do you deal with priority queues? Some messaging systems have it built in, and you can just say each message type actually has, or each message actually has a priority setting, whether it's high priority, low priority, et cetera. And you can just ask, and it just handles it, right? So you're not asking for a particular level of message, just the priority one messages come through and they will get handed out first. If your system doesn't handle priority queues, and neither the service bus nor the storage queues in Azure do, right? They just don't support that out of the box. There are a couple of ways that you can deal with this. And I kind of talked about this already. So that enables SLA priority tasks, and of course it increases complexity. So one way that people will handle it is they do separate consumers. This seems to be the very straightforward way to deal with it. You have actually separate queues. So you have priority 1 queue, priority 2 queue, and you have multiple consumers down here, each one consuming only off their particular queue. Now you can set this up with subscriptions so that the producer doesn't care or even know about this, other than maybe he knows I need to flag this as high priority, all right? But he doesn't actually have to know I need to deliver to that queue or this queue. He can just submit to the topic, and then they get distributed via the filters. Or maybe it's being done that way by customer ID, right? In the case where they've got the customer ID, the producer really doesn't care. All the customers look the same to him. So he throws a message out on the queue, but it gets put into a subscription that's a higher priority. There's a problem with this.
If you have 5 message 1s and no message 2s.
Well, that's one problem, yeah. So the observation is if you have 5 message 1 and no message 2s, you've got 2 guys up there doing a lot of work, right? And then nobody down here doing anything, right? And that can be flip-flopped, right? Underutilized, you can't scale by priority. Underutilized resources, right? So you more than likely will have less priority 1 messages than priority 2s, right? So you may have a situation where these machines are sitting up here doing nothing a good amount of time, or vice versa, as he pointed out, right? On the flip side of that, some people will go, all right, well, I'm going to write an algorithm, right? And this algorithm is going to use the same set of consumers. I'm going to reach out to one of the priority 1 queue first and ask for a message and get it and process that first. And if there aren't any messages on priority 1, then I'll go down to priority 2 and check with those. Well, this is nice because it's better utilization of our resources, right? But it's got a different problem, and that is the ones down in a priority 2 are going to get starved out, right? There is a chance that you will get a ton of messages come in for priority 1. And in this simple algorithm, all your resources are going to be chugging away on priority 1. Now, you might be thinking, that's fine, they're priority 1, that should happen. And that's completely fine if that works in your case. But if this is a scenario where you could completely starve out these messages, you also have to start thinking about message expiration. There are some systems or some processing that you may be doing that is time sensitive, right? I have to process this within this amount of time. Actually in Service Bus, actually in Azure Storage Queues, you got 7 days to process a message. That's the actual maximum length a message lives in storage queues. In Service Bus, their limit's not there. You can set an expiration on it if you'd like, but it's like by default, it's, well, greater than any of us are alive, right? So it will outlive the system that it's in, basically. But you can also set message expiration. If you have a scenario where a machine is constantly sending in information or something is sending in a status, well, that status may only be good for a certain period of time. And so you can set on each message, hey, this is good for the next 10 minutes, right? So if you starve out all these lower messages and they have expirations, that's going to start to be a problem unless you completely accept that your message is going to start to go away. Now, some people will look at this and go, you know, I'm sure I could write a better or more intelligent algorithm to check for P1 for a certain number of times and then come down to P2 and then look at the message depths and all that. And you certainly can. Just understand that that adds a whole lot of complexity to your system, right? Understanding which messages will get taken first. Throw on top of that more queues, right? Because as soon as you have a priority 1 and a priority 2, next requirement, almost guaranteed, there's going to be 3, 4, 5, 6, 7, et cetera, right? So keep that in mind. Any questions about priority queues? So the question is, which approach do I recommend? I'm going to take what's, sorry? Combination? Yeah. So the simple answer is going to sound flippant, but it really isn't, and that is it really depends on what these things are doing, right? If I have a system that it must know right away stop, then I'm probably not necessarily going to look at a messaging system like this. I might, but I would be more apt to, is there any way I can get a direct command channel to that thing? And if I can, then all priority messages are going to be sitting like this, and I don't care if there's 3 boxes up here doing nothing but checking that queue. That's a command, and I want it to do it right then, right? But if I back that off and I'm looking at a tenant scenario, like the example of this client gets preferential treatment, then I might do a higher level queue like this and have multiples depending on how much work he does. Or I'm going to look at the analytics of how often is he submitting things, how often am I having to scale that, how often am I having to go back. But it really depends on what the flow through your system is. And I'm going to talk a little bit here in a bit about why it's important to actually keep track of that. But this is one of those reasons. So I can't just use this in this case and use that in this case, except for if you have this must get through every time, then there needs to be a process monitoring it all the time. So has anybody got a better comment or a different angle on that? Feel free.
Well, just a comment in the first, if we go back to the previous slide, presumably, I mean, you saw representing resources as like physical boxes there, but presumably if you have one box doing all the processing, then you're not really underusing the resources.
Very, very true, right? So the observation is even if these are processes rather than individual CPUs, then it's still one box, right? Still doing work, and that's completely accurate, right? Okay. Okay. So composition. I've already kind of pointed out that one of my favorites is pipes and filters, right? Because that allows you to do a lot of composition and build things up. But you can even go beyond that and say, look, I'm going to have a message come in, and there's going to be a subscription base, and then one of those subscribers is a pipes and filters, right? Now, obviously, we are greatly increasing complexity here. But this gives you a very flexible system that you can add things into, you can change the way that things work. If you have your filtering being done either through subscription filters or if you've got a routing system put into place, you can handle this and introduce all sorts of new functionality into your system without going back to the individual consumers or producers and changing them, right? But I will say that documentation here is just a must. You must have this documented. So we've talked about a few patterns, right? You may be thinking, hey, this is great. This sounds very flexible. We're going to add some things in, and I'll go back and start that on Monday. Anybody doing this Monday? Anybody already working on a messaging system on Monday? All right, one. All right. So there are some issues that you need to also think about. It's the concept of poisonous messages. And in several places that I've been that are especially new to messaging, they don't think about this right away, right? Because this person is writing it's the very first thing they're implementing, right? So one producer producing a message that the one consumer knows how to deal with, right? So they don't really think about it. Once you start getting into a messaging environment where there's messages going all over the place, right? You can suddenly have all sorts of interesting things, like someone misconfigured and a different queue is getting the messages meant for somebody else. So what happens with a poisonous message is the consumer pulls that message off and he starts to work with it, but he doesn't know how to deal with it. So he blows up, right? Or he at least goes, bah, I don't know, right? So this can happen because the wrong message got delivered to the queue that he's consuming. It can also, I've seen it happen where people were serializing the object, right? So they took the object, they serialized it, put that in the message and sent it across, and they didn't serialize it with JSON or something like that, so they binary serialized it. And the guy picked it up on the other side, for whatever reason, was out of sync in the versions of that object. And in some cases, the serializer just works and the default values get set and it's fine, and in other cases, it'll blow up, right? So there's a lot of reasons that poisonous messages can come into the system. But one of the problems with them is that they can actually bog down your system. So if you have, let's say, two processes or two consumers that are working through these messages, and somehow 50, 60 of these poisonous messages get into your system, well, every time one of the consumers, this is first in, first out, right? So every time one of the consumers asks for a message, he's going to get handed a poisonous message. Oh, blow that. I'll put that back up there. Give me another one. All right, well, okay, that one's bad, bad, right? And it looks like a person that collects cards, right? Got it, got it, got it, got it. Need it? We'll process that. Got it, right? So poisonous messages can bring your system actually to a crawl. And if you have auto-scaling put into your system based on the depth of the queue, you want to talk about something that will crank your expenditure up quite heavily, this will do it, right? So you need to have something into the system to detect them. Now again, a lot of the messaging frameworks actually have stuff built in to handle duplicate messages, or sorry, not duplicate, poisonous messages, right? In some cases, it's as simple as you pull the message off, and if it gets pulled off so many times, the framework realizes this is bad, so I'm going to dump it into what's called a dead letter queue, right? And a dead letter queue generally is just, again, another queue, but the processor for that guy is probably a human and not necessarily code, okay? The other thing that people will do is they'll take the message and they'll dump it. If the framework doesn't have anything built in, then they'll take that message and they'll dump it into a database and say, here, deal with this, right? And then that way, someone can actually work it like an actual heap. Oh, I know what to do with this one. I know what to do with that one. That's actually one of my problems with service bus brokered messaging has automatic duplicate or automatic poisonous messaging, right? So if it pulls a message more than 10 times and you can set that value, it'll automatically dead letter it. But it adds it to another queue. And while I can go in and individually look at what's in that queue, I can't work them individually, right? I have to work in a queue from the front to back, right? Now, the storage queues in Azure do not have automatic dead lettering, but they do have a property on the message. So as you pull the message off, it has a property called DQ count. And that just tells you how many times it's been pulled. And then you can manually decide to do something at that point. You can manually say, well, I need to put that into my own dead letter queue or a database or something like that, have somebody look at it. But again, one of the mistakes that I have seen people do with messaging is they don't think through what happens when we get a poisonous message? How do we resolve them? How do we get them off the queue? How do we detect them, right? So usually what happens is everything's going fine. They implement the second message or maybe the third or fourth message in their system, and then you do a rollout and somebody changes configuration, and then all of a sudden they start seeing their queue length go really high, right? And they look in their logging, if they put logging in, and it says exception, 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 okay? So don't be those people, right? Think about what you're gonna do with poisonous messages up front. I'm also gonna talk about test messages. Now, when I'm saying a test message, this can take a couple of different forms. And then there's another message type I'm gonna talk about here in a second, and I don't want you to get them confused. So I worked on a system that we had multiple customers, right? So we had a lot of different customers, and they were all putting messages into the same queue, and we had heuristics for all sorts of stuff. Remember the priority queue stuff? And at some point, we would get a complaint, right, in production. Hey, this isn't quite working, or this value didn't get set correctly like I expected it to from a customer. Okay, so we go and we run it through the test system, as in the test environment, and we can't recreate it. Okay, so maybe somebody screwed up our production config. So what happens, how can we test the flow through the system, right? And how can we test that each step is doing what it's supposed to do? Now, because we had individual customers, this was actually kind of easy. We just created a fake customer in the system, right? And then we could go in and set him up to look like the other guy, and then drop the message in and see it go through the system, and test, hey, this is a test, so I'm going to do this processing. Now, in that case, it was easy because it could actively do the processing and be fine, right? And we were just looking at the end result. I have seen other people do this where they drop a test message in, and each component along the way that's doing processing can look that up and sees that test flag and behaves differently, okay? That's not as nice because you're not actually seeing the production system do what it's supposed to do. But it would do something. It would say, hey, I'm here, right? But think about places in your processing in which you need to know, did this occur, or did it occur the way we expect it to? A lot of people get away with this by just adding a decent amount of logging to the process for each step, right? So this is another type of message and this isn't even a type of message. This is something that you just should be doing. And this is tracing all the messages through your system, right? You don't have to keep the data for very long, especially if you're pumping a ton of messages through the system. You do not need to keep this data very long because you'll get tons and tons and tons of data. But you want to be able to trace this through for a couple of reasons. One, especially in the scenario where you've got pipes and filters or a dynamic pipeline that you're building up, you need to be able to know, did that message flow through the way I expected it to actually go? Or is it getting lost in the system, right? And so this can be done fairly easily with just tracing messages or having it log, hey, I went to this, I did this process step, hey, I did this process step, and then you'd go query your logs to figure out, here's the message ID, here's all the steps that it did, right? For debugging, this is almost a must, right? You will pull hair out, right, if you don't have that or something like it. Along with that is you don't want to lose messages, okay? Messages can come in, and as we've talked about earlier, right, the whole tree falling in the woods thing, as the message comes through, if it gets to a scenario where there's a filter or a subscription, there's a possibility it could just disappear, right? Because all of these guys could be filtering. So there are subscriptions, but they're not listening for whatever that message is or whatever that flag is. And so it just disappears. So tracing messages are going to help you detect this, right? Hey, it got to this point and it stopped. Why did it stop, right? Another thing is, again, that subscription and service bus that you can do where you're saying, I'm going to subscribe to a catch-all, basically. If you haven't delivered to anybody, deliver to me. And then you can actually watch that subscription queue for anything that appears in there. Because if it's more than 0, something's wrong, right? Either that message isn't expected to go anywhere, and then you can go, okay, that's fine. Or it might be, no, we've got a configuration problem here. Now we've got messages that are basically dropping on the floor. Okay? And in those scenarios, you also need to think about ways, either through your application or through a command line tool or a DevOps tool or something, to be able to take a message from back here that has fallen into this no man's land and resubmit it once you've fixed the configuration problem, right? So that's something else that will need to be tooling that you'll need to put in place or have on hand, right? Some way, some easy way for you to go, all right, take this message and put it over here, right? And get it to go flow back through the system, okay? Questions about that?
Do you do the tracing messages with something like correlation ID or something like that?
So the question is, when you do tracing messages, do you use a correlation ID? So at least for the Azure stuff, both at storage queues and service bus queues support a message ID, and I usually use that. However, if I have a correlation ID, I tend to refer to correlation IDs for something that the front end was looking for. However, it could also be said this message is the same or correlated across all of these steps, in which case I would use the message ID. Does that make sense?
Yeah, do you not get a different message ID depending on, if you
Oh, no, okay.
one queue to another?
So the question is, so if it moves from one queue to another, do you give a different message ID? In both those, I can actually set the message ID when I hand it in. Right. If I don't set it, then it gives it one. Okay. So, but yeah. So to me, I use it that way, is to identify this message uniquely across all the queues. That's a perfectly acceptable definition for a correlation ID. It's just from the systems I've worked on in the past, it usually means there was a process that happened up here on the front end that I need to be able to correlate that back to this whole system back here, what he was doing, and see a log of user did this, bought the system, or bought the order, and then the order message went through here, and then went into the database, right? And then I can use the correlation ID to cover that whole thing, whereas the tracing was just the message ID. But yeah. Any other questions? Cool. So one of the other things that I will harp on quite a bit, again with the tracing messages and why they're important, is getting what's called functional transparency. This is just a fancy way of saying you know what in the world's going on, right? You need to be able to look into the system and see how is it operating and is it doing it well. So some of the metrics that people usually look at is queue depth, right? How many messages are in this queue? And they may look at that as, if that queue depth gets too long, then I need to start adding in more processors, right, to pick up the slack. One of the things that I think fewer people think about is the timing on each one of your processes. You should record how long it takes you to actually process each message so that you can get an average. Because I can look at this and say, oh my God, there's 50 messages or 50,000 messages now in this thing. I need to scale up. Well, the question is, well, how many machines are you going to add? How do you know how many machines to add if you don't know how long it already normally takes to process a message of that kind, right? So that will help you make decisions on, when I scale up, I need to, based on this queue depth, I need to scale up by a factor of 2, or I need to add 10 machines in order to get through this backlog in a reasonable amount of time, right? So in addition to actually tracing the information or tracing the message through, when you're done or when you're sending that, hey, I'm done, I've completed this, you need to capture how long did it take me to do that entire process. And then look at that data. And it can tell you all sorts of neat things. We had a system where everything was going along swimmingly until one of our queue places, one of our particular processors started to have a problem. We got an alert basically that said, hey, your queue is way too long, and auto-scaling has started to kick in. Like, okay, so what's going on with it? And we go in and we look. We had no idea how long each one of them was taking. And so we got bit by, well, how many machines do you need to add? I don't know, add 2. We'll see where that goes. Add 3. Oh my God, that's really not helping. And we went in and looked at the logs, and what was happening was we were using a third-party system in this processing bit. And what used to take 20, 30 milliseconds to do a process was taking 20 to 30 seconds. And that's because when we went out to that third-party call, they were having a problem. We were getting throttled. And it's like, all right, well, it doesn't matter how many machines we throw at that. It's not going to solve the problem. So When we built timings in, then we can get all sorts of stuff looked at, right? So not only does the queue depth matter, but we had an alert to say, hey, if this particular processing step started to take longer than X, then we need to alert on that too. And then we can look at that and say, is that a problem on our end? Is scaling going to fix that? Or is it not going to fix that, right? So having functional transparency built in is very paramount. Aha, compensating logic. So earlier we talked about item potency, right? Try to make it to where you can run it as many times as you can. Unfortunately, there's very few things that I've actually done that are item potent by nature, right? Especially if you have a pipes and filters, right? Because there's no distributed transaction that goes across that whole thing, right? Each one of those guys is doing their work. And if you have a scenario where it gets through the system and you realize, no, I need to roll that back, maybe it's at a certain point. If you haven't thought about this, what this normally turns into is you going to the database guy, getting down on your hands and knees and saying, please write a script to fix this, right? Roll that back. And that's not a good way to start a day for the DBA. You need to think about, how can I reverse this? And there's a lot of different approaches to it. Some people actually, it's so simple, or so it happens so infrequently that they literally do just have a script that goes and fixes the data on the back end, right? That may or may not work for you. Some people will do something like this. So they'll actually have a reverse pipeline, right? So the message comes in, and if it gets to a certain point and fails, then it just gets thrown back onto another pipeline, and it goes back through the pipeline in reverse order. And each one of these components have an execute method, basically, or a do work method, which is what it executes on as it goes through. And then on the way back through, it's got a compensate method, and it knows how to deal with that, okay? That works in some cases. Again, it really depends on what your system is doing. And even this obviously doesn't have a distributed transaction that goes across the whole thing, right? So anytime that you have a system in which you can't actually use a distributed transaction, you're going to have things in place to be able to have compensating logic. So if I added this file, right, this photograph, and I resize it, put it in the location, well, the compensating logic for that would be delete the file. That's pretty straightforward. If I have charge this guy's credit card, and I get back to my compensating logic, well, I got to call or make a call to the payment gateway and say, revert that, refund that, right? So again, thinking through each one of your steps, what does it do, and then how can I make it not do that or revert it to where it's back to normal? And there will be some scenarios, sadly, that you'll get to, you're like, this is going to be hard. And there won't be an easy answer to it. And that wasn't supposed to move. Excellent. So, questions about compensating logic? Okay. So, another process I'm going to put up here, or another idea. Now I'm starting to, I should not have called it a gateway. But how many people have worked on a project in which someone, architect, or maybe someone who comes up with a requirement of, hey, we need to be able to swap the databases in and out in the back end. So how many people have worked on that project where you have written an interface that the whole point being that eventually you'll be able to go into the database and remove SQL Server implementation and input Oracle implementation? How many people? Did you ever swap it out? Yes? Yeah, once. I know why I ended up having to swap mine out. Why did you have to end up swapping yours out? Licensing? Okay. So I have worked on a ton of projects in which that was a goal. Database agnostic, persistence agnostic. Okay, that's fine if it's needed. And it's, having an interface, there's nothing wrong with having an interface. But being able to use that to swap it out, is that really the reason you want the interface, right? In my particular case, I had to do it because we were writing an application that would then be installed at different client systems. And that one client had SQL Server, one client had Oracle, one client. So we had that requirement up front. All the other times I've done it was a complete waste of time. And inevitably, when somebody actually did go in to swap it, all the horror stories I've heard is, well, we were using X feature in that database and the other database didn't have it, right? And so when we went to swap it out, we really end up having to change a whole bunch of stuff anyway. So I say that, and then I'm going to say, think about putting in an abstraction layer when you do your messaging. But it will have the same caveats, right? Do you need it or not? The big one here is, if I actually have the same kind of scenario where I'm an ISV and I'm going to write software that's then going to be hosted on a particular person's site, like on premises. They may be using MSMQ. They may be using Amazon's SQS. I don't know, right? So I need to be able to plug in different implementations. Now that's great. That's a nice way to handle it. Another reason you might think of having an abstraction layer here is early on I showed the ticket pattern. Right? So the producer actually had to go push the image down to another store and then or that data down to another store and then put a message on a queue. If you segment that out and actually have an abstraction to where it's, hey, send this message, and you hand the object, or here's the data structure that my app knows about, here you go. Then you can abstract away the fact that, oh, this message is pretty big. I'm going to go push this down over here, and I'm going to put this message on the queue. And then on the consuming side, same kind of thing. The consumer there understands, I pull the message, I go get the data, put it together, put it into an object form or a data structure form that my consumer actually cares about, and then I pass that out, right? So that allows me to abstract a couple of different things. So if you have certain scenarios, at least or if you're looking at messaging, at least take a minute to say, does it make sense to have an abstraction here when we're sending messages in? Does my producer code actually need to talk to the framework itself or the infrastructure itself, or do I need an abstraction here? Some people will automatically say yes, that's fine. Some people will go, no, not really. Once you start dealing with abstractions, especially if you're going to swap them out, you'll end up with the scenarios of this framework can handle these things, this framework can handle those things, and you end up getting down to a lowest common denominator, right? And in some cases, that's fine. In other cases, it's not. So I actually did this and had an abstraction layer for the ticketing system, and it was smart enough to understand this data is too big, so I'm going to break it up and send it across. Or it could look at it and go, no, this data is just fine, so I'm going to send it across. And we did that for efficiency reasons so that we weren't constantly going out to that third party, or actually the storage location we were sending it to when we broke it apart. Does that make sense? So just at least take a think about this. So any questions about that? Okay. So I'm going to start wrapping things up, and I've got plenty of time for questions. So with messaging, you get a lot of benefits, right? You're going to get the scalability, so you can scale your system a little bit better. You're going to get a lot of flexibility, and you're going to get that temporal decoupling, that fancy term for just separating the processing in time, right, and actually breaking that apart. But what you will run into for issues sometimes is ordering and grouping, and that's pretty much for any messaging system. You have to understand, is it truly FIFO, and do I really need that, right? And then complexity, and I can't, actually I probably could harp on this enough, but you just really have to think through, what is my messaging system doing? How is it constructing that pipeline? Do I have to have a pipeline? Do I really need to make this overly complex, right? I have actually seen people go through the process of breaking this apart, running through the whole system, having this huge messaging system apart, and then you look at the timings of when it was all together as one big monolithic thing, and it took, let's say, 10 seconds. But by the time it ran through this whole thing, it was a minute and a half. And it's like, all right, if you're breaking that apart because there's a user involved and you want that user to have instantaneous feedback, that's awesome, that's fine. But if it's just an app sitting out there doing this processing, then let it wait 10 seconds, right? So think that through. I talked a little bit about Azure today, specifically around their queuing services and whatnot. If you have an interest in Azure, justazure.com is a website that I help edit. And there's all sorts of articles out there about Azure. So if you're interested in Azure or getting started in Azure, there's several series out you can go look at. In addition to that, there's actually an event going on April 25th. It says global. There's one here in London, but it's actually global because on April 25th, across all time zones, well, not all time zones, but many time zones, we have about 147 locations around the world that are all meeting that day to talk about Azure. So if you have any interest, take a look at that. It's being run by the UK Azure User Group. If you're not familiar with them and you're interested in Azure, definitely look them up. They're a meetup that occurs here in London about once every month. Their meeting this month is actually tonight. So with that, here's my contact information again. If you want to send me a question or send rants at me for how badly I did, that's fine. But I'd love to hear from you. Feel free to come up and get a business card. But I will certainly take questions afterwards, but thank you for your time. Has anybody got any questions? Yes, sir.
Just about, so you didn't really talk anything about message payload, so I just wondered whether you had any sort of general comments or advice about that. I was thinking particularly about versioning, so if you've got multiple versions of a message, how you handle that if you're consuming it.
Okay, so that's a great question. The question is, what's the advice on dealing with different versions of the payload, right, as you pass through? So there's a couple of ways that I've handled that in the past. The most simplistic way that I handled it is I had a router in the consumer part, so there was an abstraction that was taking the messages off the queue, and he basically was a dispatcher, and he looked at the header on the message, on a header that was on the message, and it knew what version it was, and then handed it off to a consumer that was specifically coded for that guy. So we would do rolling versions of the consumers that were out there, and they were just different processes that could be handed off to, either different queues or whatnot, and you can even end up, if you wanted to abstract that further back, we weren't doing pub sub at the time, but if you wanted to abstract that further back and say, messages that come into this topic, they look at the message header and then they drop it to the subscription that knows how to deal with it. That's a much cleaner way to deal with it than what we were doing, but we weren't doing pub sub at the time. So, does that work? Anybody else? Yes, sir.
About the bad messages, there are two things as you mentioned about like the data queue or to put the message into the database. Is there any good design pattern apart from these two?
So the question is, when you're talking about poisonous messages, I gave the options, put in another queue or put it in the database. Is there a better way to deal with that or a different way to deal with that? It's computer science, so there's a ton of different ways you can handle each thing. If it's a scenario where it's going to end up, you're going to be processing a lot of these things for some reason, then I tend to say I want to get that out of a queue, per se, and get it into a database or into a stack, or not a stack, a heap of some kind, right? Maybe I just persist it out to drive somewhere. Because I want to be able to process that out of order. I want to be able to go in and say, these 15 poisonous messages we can just delete. These 5 poisonous messages, I just need to change. I just need to deliver them to a different queue, right? And a human's going to process that way, right? If you're dumping to a human, then getting it out of a queue is probably your better bet. If it's a machine that's looking at it, then let it just be a queue, right? Because it doesn't matter to it. So, does that help?
Yeah.
Anybody else? You in the green?
Is there a pattern for if you've got multiple consumers, but all which specialise, and say they each take similar messages, but some can only take a particular type? Is there a particular pattern? Would you advise on that?
So the question is, if you have certain consumers that can only take certain kinds of messages, is there a pattern to deal with that? And that's just publish and subscribe, right? Or deliver to particular queues. So you can have a queue that's dedicated to a particular type of message if you want, but if you're trying to share as much resources as you want, there's a lot of times we end up with a scenario where the consumers are they just have an index of these are the types of messages that I know how to deal with. And so I'm going to pull from these types of queues because I know they have those. Or I'm looking at a subscription that I'm subscribed to only this guy, he only gets these type of messages, so I'm good for that, right? So I would look at subscriptions there, right? Or something along those lines, or publish, subscribe, right? Now, if you have a scenario where you have a consumer that's actually smart enough to process 18 different types of messages. It's just, he gets it, looks at it, goes, oh, it's this thing, I'm going to process it this way. Then that just comes back to, you need to make sure that the ones that, so that he becomes a dispatcher at that point, and he can either look at it and say, I know how to deal with this and I'm going to process it, or I don't know how to deal with this, I'm going to pass it along. So it really depends on where you want to do the routing. Do you want to do the routing up front, or do you want to do it when the consumer pulls it? Does that help at all?
Yeah.
Okay, so to me, the pattern there is, I would look at handling that with a subscription. So these are the guys that run, and I might have multiple processors. As the gentleman up here pointed out, I might have actually multiple processors running, multiple processes running as consumers on the same box, but they're all pulling different messages, right? But that you really have to look at. I didn't talk about this, but if you do that, if you have a single consumer machine, physical machine or VM, that's processing multiple types of messages in different processes, you need to be very careful that you don't basically just overcrowd the box, right, and start starving each other out, right? So again, functional transparency to understand, am I getting some thrashing here because it keeps switching back and forth? Do I have my multi-threading code right to handle that? But it certainly is a lot better utilization of resources than having, here's a physical box that processes these messages, and here's one that processes those messages. So, you had a question? Yes, or did you raise your hand? Yes.
You mentioned it earlier on about the value of documentation, and I totally get the value of documentation, because as soon as you started talking about the things that can go wrong and the way you monitor it, you were putting up diagrams to explain what the structure was so that you could see where you were. So I totally get that.
Yep.
What I don't understand is that you were talking too about being able to change that topology on the fly.
Yes.
And so you have this dynamism going on. How do you keep track of that? What sort of diagrams do you draw and how do you express that?
So the question is, documentation is great. How do I deal with that on the fly when you're rebuilding pipelines, right? So there, I'm not really looking at a diagram, right? What I would end up doing is taking a look and documenting the construction of the pipeline. Why, if I have, in the particular case that I gave, there were two different pipelines. There was one that had the special case of processing the watermark and one that didn't. So I would document, here's the pipeline order if it's a special customer. And then here's the pipeline order if it's not, right? And then based on that pipeline order, and it doesn't have to be complex, right? It's just a list of the filters in the order that they should appear. And then I can go and I can look at my tracing messages and go, yep, it's going in that order. Oh, this guy's went in that order, but he's not a special customer, so that's a problem, right? But that's versus if you don't have that at all, and then you're a new person coming onto the system and you sit down and someone says, well, I didn't get processed fast enough. Okay, is that because that guy's queue was that slow, or did he get into the wrong queue, or what, right? Having that documentation allows them to at least see, well, it should be going through these steps. Now I'm going to dig through the log, look through the tracing message, the correlation ID. Did it go through the steps that it should? And, oh, here's the timings for those. So, anybody else? Yes, sir.
Is there any way to protect against misbehaving consumers?
Misbehaving consumers. So, how to protect against, like a DDoS attack or something? They're just shoving a bunch of stuff, or?
Like if you explained one of the pattern where the consumer basically they are using transactions, so
Mhm.
they can keep reading the message, thousands of messages without committing. So the message disappears from the queue, but it's still there because they haven't committed the transaction.
Okay.
They say, okay, I'm going to keep reading the messages,
Yeah.
and after reading thousands of messages, suddenly something happens at the consumer end, and they roll back the transaction. So suddenly you have thousands of messages in the brokers, and it suddenly just gives up because I can handle those many messages in my system.
So, in the end, well, let me back up here. So, if you have the scenario that your consumer, or so it's misbehaving consumers or producers? Consumers. So the consumer pulls a message. He's got a certain amount of time to finish that message. If it appears back on the queue, then if he just constantly keeps doing that, then, and if he gets the same message, it's going to look like a poison message. However, if he's consistently putting that message back saying this is wrong, this is wrong, this is wrong, you could do some analytics to say, here's my error logs coming in, here's this one consumer that constantly keeps failing. even across messages. But there's really nothing that's going to tell you that unless you build it in. You're going to have to know he explicitly is blowing up on every single message he deals with, right? So it becomes takes it out of the realm of a poisonous message and puts it into a misbehaving consumer, right? In some cases, I don't think you'll ever end up in a scenario where your system will just completely fold. What you'll get is you possibly could get to the point where it doesn't matter how many producers or consumers we throw at this, we're never really going to get through our backlog. And that can be very daunting, and it's usually a bad conversation because what you end up saying is you end up going to the boss and say, I need a lot more resources to catch back up. So my suggestion there would be not so much how to handle it, but how to prevent it would be look through your analytics or put analytics in the system that will detect, I have got consumer B, and he has errored out on the last 15 messages that he has pulled. So that's a great little alert to have because it'll tell you about misbehaving consumers, but it will also tell you I've got poisonous messages in here. Could also tell you that, right? And there's a lot of different analytics frameworks out there that you can plug into and be feeding data, most of which are message-based. But you can then analyze that as it's coming through and say, hey, okay, I've gotten 10 of these from this guy in the last 2 minutes. That's a problem. So I would generally try to handle that more from prevention because once it actually happens, you need to be able to go in there and shut that machine off, right? Get him to stop taking things, and then look at how deep is your queue and is it reasonable to get through that. Depending on what your processing is doing, I haven't run into a system, I take that back. One time I ran into a system where we calculated with the backlog that we have in there, it'll take us 2.4 years to process everything that's in here. Luckily, we were like, oh, that's log data, just dump that, right? It was just telemetry data that we didn't, it's nice for debugging, but oh well. Because we just couldn't throw enough resources at it to get through the system. Anybody else? Any other questions? Yes, sir.
Could be quite similar to the previous question, but it's all about misbehaving consumers around what they're talking to. Because in our system, we're using messages to send commands to devices.
Mm-hmm.
If those devices, too many of them go offline, they choke up too many of the queues, and then it kind of slows down the whole system. How would you solve that issue?
Okay, so the question is, what will you deal with if your producers or your consumers are just offline, right? Or they go offline or they have problems, and again, chokes up the system. This is related the same way, right? The beauty of the messages is they're always there, right? Durable persisted messages means that it's there. And even if I have to take off and shut down every single one of the consumers for some reason, I know that eventually when I come back up, it will spin back up. Now, if I've got actual users sitting on the other end, that's a bigger problem, right? And if they're actually expecting a result, that's a big problem. But a lot of the messaging systems I've worked with is, again, there's a reason we're decoupling it so they can get an immediate thank you and we'll get back to you later. So I've had that problem where the back end we rolled out an update and it biffed, it blew out the whole thing. Every message just died, right? Or every consumer just died when it was trying to process. And we were down for 6 or 7 hours. But when we brought them back up and had the fix in, it would just run through it. Again, it's not a matter of what do you do in that scenario. It's identifying the problem. If all of them are having a problem, let's shut them down. Again, functional transparency will tell you, if you have it built in, all of these are having problems. It's not just your log filling up, right? Or just one guy that's acting bad. So get them shut down and figure out what the problem is and then deploy a fix and get them back up. And again, having that average time to do the processing will tell you how many machines do I need to throw at that to be able to get through that backlog. I've been on projects where there's some tense time where we're like, all right, well, we're going to borrow some of these guys' machines to come over here and do this processing, and these later steps down the line, we're stealing machines from them to deal with this, and then slowly bleeding them back off. So I know that's not a direct do this, but it kind of boils down to that's one of the benefits of messaging is that you can have that whole back end just shut off. And when it starts back up, it'll pick up from where it was.
Well, so in this case, the problem is that it's the things that the consumers are talking to that are the issue. So if a device
Yes. Yes. Okay. So the scenario is here, whether it's a database, the consumer is pushing into a database, or it's talking to a machine and it's telling you to do something. That's a scenario that I would say you, again, need to have good logging analytics on to realize I'm having that problem. I cannot communicate to that. So it's blowing up not because it's bad or I've got a bug in my code, but I cannot insert into the database. In those cases, I always recommend having retry logic in, right? Because you never know if it's a transient error. I go to push to the database, oh, I get my favorite, how many people in the room have been victims of a deadlock? Anybody? Yeah. So what do? Right? You try it again, it's immediate, right? It works, that's awesome. And then you send the DBA an email and go, why in the world are we getting this? But have retry logic in there, but have basically an algorithm that says, if I try this 3 times in this amount of time and it's not going, then this is a problem. So I'm going to flag that. And then I'm going to let the message just go back, right? And if I get so many of those, right, in a short amount of time span, then maybe I just send a command out that shuts down all those consumers and sends somebody a text message that says, go fix this. But absolutely, again, that goes back to functional transparency, knowing what your system is doing at all times, and is it what it's supposed to be doing? Anybody else? Yes, sir.
It sounds like health monitoring is key to
Yes.
Do you have any tools you recommend for doing health monitoring?
So the question is, do I have any tools for health monitoring? I've worked with a lot of different ones. There's just from custom logging stuff up to New Relic to other systems, right? I don't have any that I would actually recommend, mainly because I'll end up recommending it and then someone will go look at that one and they go, well, that one's too expensive, or that one's too cheap, or that one's free but there's no support. So I always say, just research what you're trying to get out of it. Can you put messages in? And if you're trying to do data analytics, will it give you that? Right? Can I do an analysis to say, I got this many messages came through in this amount of time that were a failure, I want to be able to flag on that and do an action. That's the requirement that I have for any health monitoring system I use. All right, well, thank you all very much for your time. Some really great questions. And I hope you guys enjoy the rest of the DevWeek.